Hello friends, now we'll start the first chapter, Laws of Motion. I will explain all the concept, all the rules and the derivations of this chapter in a very simple language. मी हे शिकवताना दोन्ही भाषेत बोलणार आहे, इंग्रजी आणि त्याचबरोबर मराठीत देखील. Now let us start. Now in this chapter, what you are going to learn? The first is motion, distance and displacement, acceleration, and last, Newton's laws of motion and related equations. The first is motion of an object. Can you tell in which of the following examples you can sense motion? How will you explain presence and absence of motion? The first is the flight of a bird. Now see this here. This is the flight of the bird. Here is a presence of a motion. Next, a stationary train. See this here. Here is a absence of motion. Third is leaves flying through air, and here is a presence of motions. Next, a stone lying on a hill. Now here is a absence of motion. Okay. Therefore, now here we will conclude that we can sense motion in the examples 1. The flight of a bird, and third, leaves flying through air. यामध्ये आपल्याला मोशन बघायला मिळते. Okay. Therefore, a body is said to be in motion if it changes its position with respect to its surrounding and at rest otherwise. This is the definition of motion. Now next, see this here. Again I will repeat here the definition of the motion. A body is said to be in motion if it changes its position with respect to surrounding and at rest otherwise. जर त्या बॉडीची पोझिशन चेंज होत नसेल तर ती कशी असणार आहे, तर ती रेस्ट असणार आहे. We see the motion of several objects every day. Sometimes we cannot see the motion of an object directly, as in case of a breeze. Okay. Can you list other examples of motion besides those given here? Now see this here. The examples of motion are waterfall, released arrow, passing through air, a moving bus, a boy riding cycle, etc. These are the examples of motion. See this here. Moving bus, it changes its position with respect to surrounding. Next, waterfall. Next is released arrow passing through air, and a boy riding cycle. It changes its position with respect to surrounding, and hence we say that he is in motion. These are the examples of motion. Next, motion of windmill. Okay. And next is a motion of branches of trees in storm. Okay. These are the examples of motion. Now, next, think about it. You are traveling in a bus. Is the person sitting next to you in motion? The person sitting next to me is not in motion with respect to me. आपण बसमधनं प्रवास करताना आपल्या समोर दुसरी व्यक्ती असेल तर ती आपल्याला मोशनमध्ये, गतीमध्ये असणार आहे का, तर नाही. बट दॅट पर्सन इज इन मोशन with respect to a person on the road. त्याच बसच्या बाहेरून जे कोणी असतील बघणारे त्या पर्सनकडे, तर ती व्यक्ती कशी असणार त्यांच्या दृष्टीने? ही इज इन मोशन. ओके, नाव सी दिस हियर, these are the two persons. If one person sees the another, there he will say that he is not in motion. But the person outside this road, if they see these two persons, then these two persons are in motion. Okay, again, here the bus changes its position with respect to surrounding. Therefore, this bus is in motion. Okay. Next, what do you take into consideration to decide if an object is moving or not? Okay. To decide whether an object is in motion or not, we consider whether it changes its position with respect to its surrounding or not. त्याच्या सराउंडिंगच्या दृष्टीने ती ऑब्जेक्ट तिची पोझिशन जर बदलत असेल, then it is in motion. If it does not change its position, then we say that that object is not in a motion. Okay, now your bus is changing its position with respect to surrounding, therefore it is in motion. You have learned that the motion is a relative concept. Motion of an object, its a definition is, if the position of an object is changing with respect to its surroundings, then it is said to be in motion. Otherwise, it is said to be at rest. Okay, now the next, displacement and distance. Next topic is displacement and distance. Let's try this. Okay, now see this the figure. First, measure the distance between points A and B in different ways as shown in figure 1.1a. Okay, now measure the distance between A and B in different ways. See this here, from A you can measure like this. Next you can measure also it like this, number of the ways are there. Or you can measure straight directly from A to B, shows in dotted line. Okay, this is the first way, that is a in between. This is the way, that is a A, X, B. This is the first way. This is the straight way from A to B. O is in between A and B, that is a AOB. And the next is a AYB. Okay. Distance between points A and B can be measured along three different lengths. That is, the first is AXB, second is AOB, and third is AYB as shown. Three lengths measured will have different values. Okay. Now measure the distance along the dotted line. Which distance is correct according to U and Y? Okay, which distance will be correct? Now the answer is distance measured along straight line AOB is most appropriate. This is because there can be infinite path to connect point A to B. Okay, a straight line path is conventionally accepted as a standard in such a case. Okay, also error while measuring the curved lengths such as along the AXB or the length with loop such as AYB is likely to be more than error than that may occur while measuring linear distance along AOB. Therefore, a distance AOB is a more appropriate. म्हणजे A पासून B पर्यंत X मार्गाने जाताना आणि A पासून B पर्यंत Y मार्गाने जाताना हे अधिक योग्य होणार नाही. तर काय होणार आहे, तर A पासून B पर्यंत स्ट्रेट जसं आपण जाऊ ते मोर ॲप्रोप्रिएट असणार आहे टू मेजर द डिस्टन्स बिटवीन द पॉइंट A and B. Okay, now the next, see this here the figure. First, A. Sheetal first went to her friend Sangeeta's house on her way to school. Here is a Sheetal went to first Sangeeta's house. He traveled the distance of 500 meter, walked the distance of 500 meter, and then 1200 meter from Sangeeta's house to school. Okay. Prashant went straight from home to school. Okay, Prashant went from home to school directly. He walked the distance 1300 meter. By both are walking with the same speed. Next, who will take less time to reach the school and why? Okay. In the above example, is there a difference between the actual distance and the distance traveled, and what is it? Okay, now we'll see the answer. The first is, who will take less time to reach school and why? Now the Prashant will take less time to reach school. Okay, see this here. Prashant will take less time than Sheetal. As Prashant and Sheetal both are walking with the same speed, time they will take to reach school will be directly proportional to distance they are traveling through. Okay. प्रशांत किती डिस्टन्स कव्हर करतोय 1300, परंतु शीतल तिला किती डिस्टन्स कव्हर करावं लागतं, दॅट इज 1200 मीटर प्लस 500, दॅट इज 1700 मीटर. ओके, त्या दोघांचा स्पीड कसा आहे तर सेम आहे. Since the Sheetal covers more distance than Prashant, she will require more time to reach the school. Okay. That is, in the above example, is there a difference between the actual distance and the distance traveled? Okay, and what is its actual distance? किती आहे 1300 मीटर आहे. Okay, yes, there is a difference between the actual distance and the distance traveled. The actual distance between school and house along the straight line is 1300 meter. This is the straight distance. Okay, while the distance traveled by going via Sangeeta's house, okay, संगीताच्या घरावरनं जर गेलं तर ते किती डिस्टन्स लागणार आहे. Thus by changing the direction of the motion is 500 first from Sheetal's to Sangeeta's house 500 meter, and next plus 1200 meter, that is the total is 1700 meter. Okay, thus the distance traveled in this case by the Sheetal is greater than the actual distance. Actual distance किती होता था 1300 meter. Okay, the next, therefore we can define displacement and distance. What is that distance means? Distance is the length of the actual path traveled by an object in motion while going from one point to another. Okay, distance is actual path traveled by an object in motion while going from one point to another. And what about the displacement? Displacement is the minimum distance between the starting and finishing point. Okay, now the next, use your brain power. Every morning Swarali walks around the edge of a circular field having a radius of 100 meters. As shown in the figure, If she start from the point A and take one round, how much distance has she walked and what is her displacement? Now see this is the figure. So Sorali start from the point A and comes to again the point A. Now here the solution. Distance walked by Swarali is equals to the circumference of the circle and that is equals to 2 pi r. That is a 2 into the value of pi is a 3.142 into radius of the circular ground. It's 100. And after simplification, you will have 628.4 meter. This is distance traveled by Swarali, walked by the Swarali. Now the displacement of Sorali as C returns to its initial point. म्हणजे सोरालीने A पासून सुरुवात केली पुन्हा A पर्यंतच आली. Therefore the displacement of Sorali as C returns to initial point. A पासून तिने सुरुवात केली पुन्हा A पर्यंतच येते ती and therefore its a displacement is 0. Therefore the distance walked by Swarali is 628.4 meter and her displacement is 0. Okay, now next. Now the next example, if a car starting from point P and goes to point Q and then returns to point P, how much distance has it traveled and what is its displacement? Now see this figure. Car starts from the point P to Q and then it returns to again point P. Now here the distance traveled by the car. First distance PQ, then the distance QP. हे दोन्ही distance P आणि Q मधलं distance किती आहे तर 360 meters. Okay, 360 plus 360, then you will get 720 meters. Okay, this is the distance traveled by the car. Okay, the displacement of the car as it returns to its original position, initial point, and therefore it is 0. Okay, therefore the displacement of the car as its return to initial point is 0. Okay, and therefore distance traveled by car is 720 meter and its displacement is 0 because it's return to its initial point. Okay, now next we'll define the speed and velocity. Now see this here. Can you recall what are vectors and scalars that you have learned in your previous standards? Okay, that is a physical quantity which has magnitude only is called a scalar quantity. Scalar म्हणजे काय की त्याला फक्त magnitude असतं. Then we say that that quantity is called the scalar quantity. It does not have direction. Distance has a magnitude but not direction. It is a scalar quantity. Next, a physical quantity which has magnitude and the direction is called a vector quantity. Displacement has magnitude and the direction. Therefore, it is a vector quantity. Therefore, to express the vector quantity, we require magnitude as well as direction. And for the scalar, only the magnitude is sufficient. Okay, now the next. Which of the quantities, that is a distance, speed, velocity, time and displacement are scalars and which are vectors? Now it's clear that the vectors are velocity and the displacement. And what about the scalars? That is the distance, speed and time. These are scalar quantities. Distance, speed and time, these have only magnitude. At the same time, velocity and the displacement have both magnitude and direction. Next, the formula for the speed. What is that? Speed is equals to total distance covered upon total time taken. ते डिस्टन्स कव्हर करण्यासाठी जो काही वेळ लागला असेल त्याने त्याला आपण ते डिवाइड करत असतो. देअरफॉर स्पीड इज इक्वल्स टू टोटल डिस्टन्स कव्हर्ड अपॉन टोटल टाइम. नाउ द definition of the speed. Speed is a distance covered by a body in unit time. Okay. What about the unit in SI and the CGS system? The unit कसा असणार आहे? Distance is measured in SI system meter upon time means what? It's a second. Therefore, SI unit is a meter per second and it is written as M per S. And what about the CGS unit? Is centimeter per second or in bracket centimeter per S. Okay, these are the units of speed. Okay, and the definition, speed ची definition काय? Speed is a distance covered by a body in unit time. Okay, speed has magnitude but not direction. Okay, एखादा खेळाडू किती वेगाने गेला, त्याने 500 मीटर्स डिस्टन्स कव्हर केलं, पण त्यावेळेस आपण असं म्हणत नाही की तो कोणत्या दिशेला गेला. Therefore, the speed has a magnitude but not direction. It is a scalar quantity. Okay. Next, velocity. Velocity is equals to displacement upon time. Okay. Now the definition of the velocity is distance travel in one direction by an object in unit time is called its a velocity. Okay. This is the distance travel in one direction by an object in unit time is called its a velocity. Again here the unit. Okay, the unit of time can be second, 1 minute, 1 hour, etc. The speed सारखीच याची देखील unit असणार आहे. Okay, if the large units are used, that is a 1 year can also be used as a unit time. Okay, the displacement that occurs in unit time is called velocity. Okay, now the unit in SI unit, displacement is measured in meter, time is second. Therefore, in SI unit, its SI unit is meter per second or it is written as M per S. And in the CGS unit is centimeter per second or in bracket centimeter per S, cm per S. Okay. आणि या दोघांची युनिट कशी आहेत? मग सारखीच आहेत, स्पीड आणि व्हेलॉसिटीची. फक्त एकच डिफरन्स आहे त्यामध्ये. स्पीड इज अ स्केलर क्वांटिटी while velocity is a vector quantity. Okay, now always remember this. What is that? The units of speed and velocity are same. In SI system, the unit is meter per second, while in CGS system, it is centimeter per second. Okay, speed is related to distance while velocity is related to displacement. And the next, if the motion is along a straight line, the values of speed and the velocity are the same. Otherwise, they can be different. कारण की स्ट्रेट लाईन मध्ये जर मोशन असेल तर स्पीड आणि वेलोसिटी या दोन्ही क्वांटिटीज कशा असणार, तर त्या सेम असणार आहे. अदरवाईज स्ट्रेट लाईन मध्ये नसेल तर ते डिफरंट असतील. वेलोसिटी इज द डिस्प्लेसमेंट that occurs in the unit time. Now next see this here. In the first example, आपण जे पहिलं एक्झाम्पल बघितलं होतं त्याच्यामध्ये आपण त्याच्या वेलोसिटीज आणि स्पीड काढणार आहोत. The straight line distance between the houses of Shital and Sangita is 500 meter. And that between Sangita's house and the school is 1200 meter. Also, the straight line distance between Shital's house and the school is 1300 meter. Suppose Shital takes 5 minutes to reach Sangita's house, then 24 minutes to reach school. From there, okay, here again is a repetition of the quantities. Shital's speed along path A या पाथपासनं शीतलचा स्पीड आपण फाइंड आउट करणार. तिने किती डिस्टन्स कव्हर केलंय? 500 मीटर. आणि तिला लागलेला डिस्टन्स अपॉन टाइम 5 मिनिट लागले. 500 मीटर अपॉन 5 मिनिट, then you will get 100 meter per minute. This is the Shital speed along the path A. Next, Shital speed along the path B. Path B means what? Sangeeta's house to school. The distance covered is 1200 meter and the time is 24 minutes. If we simplify this, then you will get 50 meter per minute. Okay. Now the Shital average speed. मग तिचा आपण average speed काढणार. Okay. Then what is the total distance he covered? That is a 500 plus 1200. That makes 1700 meter. And the total time किती येतात तो? 24 plus 5. That is equals to 29 minutes. आपण हे सिम्प्लिफाय केलं, त्याला डिवाइड केलं, तर किती मिळेल तुम्हाला? 58.6 मीटर पर मिनिट. दिस इज दी शीतल्स ॲव्हरेज स्पीड. ओके. नाव शीतल्स वेलॉसिटी. शीतलची वेलॉसिटी किती असू शकेल? दॅट इज अ स्ट्रेट डिस्टन्स बिटवीन शीतल हाऊस टू स्कूल. किती येते? 1300 मीटर. अँड टाइम किती लागलाय तिला? 29 minutes. Okay. Therefore, Shital's velocity is equals to displacement upon time. That is 1300 meter upon 29 minutes. And if we simplify it, therefore you will get Shital's velocity is equals to 44.83 meter per minute. Okay. In this way, we have calculated the Shital's speed as well as Shital's velocity. Now, next. Effect of speed and direction on velocity. वेलॉसिटीवर कोणाचा परिणाम होऊ शकतो? स्पीडचा आणि त्याचबरोबर डिरेक्शनचा. ओके. नाव सी इज द एक्झाम्पल. एक एक्झाम्पल बघणार आहोत आपण इथे. सचिन इज ट्रॅव्हलिंग ऑन अ मोटर बाईक. एक्सप्लेन what will happen if in the following events during Sachin's ride. Okay, we are going to see the effect of speed and direction on velocity. What will be the effect on velocity of the motorcycle if its speed increases or decreases but its direction remains unchanged? तो सरळ जाणार आहे. त्याचा स्पीड कमी झाला किंवा जास्त झाला तर त्याच्या वेलॉसिटीवरती काय परिणाम होणार आहे ते आपल्याला बघायचं आहे. नाव दी आन्सर इज द वेलॉसिटी ऑफ द मोटरसायकल will increase if its speed increases and it will decrease if its speed decreases. Okay. Now the next. नाव इन दिस केस आता या ठिकाणी टर्न घेतोय तो म्हणजे त्याची डिरेक्शन कशी होणार आहे? चेंज होणार आहे. इन दिस केस ऑफ अ टर्निंग ऑन द रोड will the velocity and the speed be same? Okay. In case of a turning on the road, the velocity will certainly have to be changed and usually also the speed. टर्न घेताना स्पीड कसं होतं? कमी होत असतं. Therefore the velocity and the speed will be changed. Okay. If the Sachin changes the direction of motorcycle keeping its speed constant, what will be the effect on the velocity? Okay, speed constant ठेवलाय आणि त्याचे डिरेक्शन काय केले तर ती चेंज केलेली आहे. If the speed is kept constant and the direction of the motion of the motorcycle is changed, the velocity will change in the direction. आणि velocityची त्यावेळेस डिरेक्शन कशी होणार तर चेंज होणार. Because the velocity is a vector quantity, it requires magnitude as well as direction. म्हणून इथे velocity कशी होणार तर चेंज होणार but not the magnitude. त्याचं मॅग्निट्यूड कसं असणार आहे तर ते सेम असणार आहे. जो स्पीड असणार आहे त्याचंच मॅग्निट्यूड तेच असणार आहे, परंतु व्हेलॉसिटीची डिरेक्शन मात्र इथे कशी असणार आहे तर ती बदल असणार आहे, बदल होणार आहे त्यामध्ये. ओके, नाव नेक्स्ट. If on a turning Sachin changes the direction as well as speed of motorcycle, what will the effect on its velocity? मग या ठिकाणी स्पीडचं मॅग्निट्यूड आणि डिरेक्शन दोन्ही बदलत आहेत, therefore velocity देखील त्याची बदलणार आहे. If the both the speed and the direction of motion of the motorcycle changed, the velocity will change in direction as well as in magnitude. Okay. Now, from above example, it's a clear from the above example that velocity depends on speed as well as direction, and that velocity changes by. Okay. तर velocity मध्ये केव्हा बदल होणार आहे? That the velocity changes by changing the speed while keeping the direction same. Second, velocity changes by changing the direction while keeping speed same. And third, changing both speed as well as direction. Therefore, velocity changes by changing the speed while keeping the direction same, changing the direction while keeping speed same, and the last, changing speed as well as direction. दोन्हीचे बदल केले तर velocity मध्ये देखील बदल होणार आहे. Okay. Now the next. Always remember, the first scientist to measure the speed as the distance upon time was Galileo. The speed of the sound in dry air is 343.2 meter per second, while the speed of light is about 3 into 10 raised to meter per second. The speed of revolution of Earth around the Sun is about 29,770 meter per second. हे तुम्ही लक्षात ठेवू शकताय. Now the next, uniform and non-uniform linear motion. Okay. Now the first, uniform and non-uniform linear motion. Now see this here. Uniform and non-uniform linear motion. Amar, Akbar and Anthony are traveling in different cars with different velocities. The distance covered by them during different time interval are given in the following table. Okay, time in the clock. Okay, distance traveled by Amar in kilometer, distance traveled by Akbar in kilometer, and distance traveled by Anthony in kilometer. Okay, यामध्ये टाइम इंटरवल किती 30 मिनिट्सचा घेतलेला आहे. ओके, आणि 5 पासून त्याने स्टार्ट केलेला आहे. नाव वन बाय वन. The first is, here's your brain power. What is the time interval between the notings of distances made by Amar, Akbar and Anthony? मग टाइम इंटरवल किती आहे? That is the first is 5 to 5:30, 5:30 to 6, 6 to 6:30, म्हणजे 30 मिनिट्सचा तो टाइम इंटरवल तिथे आपल्याला डिस्टन्सचं त्याने कॅल्क्युलेट केलेलं आहे. ओके, दॅट इज व्हॉट इज द टाइम इंटरवल बिटवीन दी नोटिंग्स ऑफ डिस्टन्सेस मेड बाय अमर, अकबर अँड अँथनी. त्यांचा पिरियडचा नोट डाऊन किती वेळाने केलेला आहे तर 30 मिनिट्स नंतर प्रत्येकदा केलेला आहे. ओके, देअर फॉर दी फर्स्ट आन्सर इज 30 मिनिट्स. What about the second? Who will have covered equal distance in equal intervals? Equal distance in equal interval. तर बघूया आपण. Now see this here. The first 5 to 5:30 distance covered by Amar is 0 to 20 and Akbar is 0 to 18, and distance covered by Anthony is 0 to 14. Next 5:30 to 6, then 20 to 40. म्हणजे 0 to 20 and 20 to 40 डिफरन्स इज सेम, म्हणजे 20 किलोमीटरचा आहे यामध्ये. Next, what about the Akbar 0 to 18 and 18 to 36? यामध्ये देखील डिफरन्स करेक्ट आहे. 0 to 13, 18 चा डिफरन्स आहे. 36 minus 18, अगेन 36 minus 18 is 18. हा डिफरन्स देखील कसा आहे तर तो अकबरचा इथे कॉन्स्टंट आहे. नेक्स्ट 0 to 14 अँड 14 to 28 इथे देखील फरक कितीचा आहे तर 14 किलोमीटरचा आहे. नेक्स्ट 6 to 630, 40 to 60, सेम 20 आहे. 36 and next year is a 42, and what about year 28 to 42. Now here the distance covered by Akbar in is not uniform, not constant, okay, not equal, but the distance covered by Anthony is 0 to 14, 14 to 28, 28 to 42, 42 to 56, म्हणजे किती तर 14 चा प्रत्येक ठिकाणी काय तर तो डिफरन्स आहे. अँड व्हॉट अबाउट दी अमर, यामध्ये ते याचा किती स्पीडचा फरक आहे प्रत्येकमध्ये 20-20चा आपल्याला इथे डिफरन्स मिळतो. Therefore, who has covered equal distance in equal interval of the time? That is a Amar and Anthony. Okay. Now the answer is Amar and Anthony. They covered equal distance in equal time interval. Okay. Now the next. Are all the distances covered by Akbar in the fixed time interval the same? Okay. The answer is no. Okay. Akbar has covered unequal distances in equal time interval. Okay. Next, considering the distances covered by Amar, Akbar and Anthony in fixed time intervals, what can you say about their speed? Okay. Now in every half hour, Amar covers distance of 20 kilometer. Therefore, in 1 hour, he will cover the distance of 40 kilometer. And therefore, the speed of Amar is 40 kilometer per hour. And what about Anthony? He covers distance of 14 kilometer in every half hour. Therefore, in 1 hour, he will cover the distance of 28 kilometer per hour. Therefore, speed of Anthony is 28 kilometer per hour respectively. Okay. While Akbar is traveling with non-uniform speed. Okay. अकबर कसा आहे तर तो नॉन युनिफॉर्म स्पीड मध्ये आहे, परंतु अमर आणि अँथनी हे दोन्ही कसे आहेत तर ते युनिफॉर्म स्पीड मध्ये आहेत. Therefore, what is the conclusion? If an object covers equal distances in equal time intervals, it is said to be moving with uniform speed. And if an object covers unequal distances in equal time intervals, it is said to be moving with non-uniform speed. For example, the motion of a vehicle being driven through heavy traffic. जर ट्रॅफिक जास्त असेल तर आपला स्पीड हा युनिफॉर्म नसतो. इट्स अ नॉन युनिफॉर्म स्पीड. ओके. And in this way, we have completed the two topics, that is a motion and distance and displacement. In my next video, I will cover acceleration and Newton's laws of motion and related equations. Till then, goodbye. Now we'll see in the next video. Till then, goodbye.